Trigonometric identities. Let's have a look at these. This here is an equation. You should be used to this. Solve for x. If we multiply it out, 3 times x plus 7, I don't get 2x minus 5. I should get 3x plus 21. But hang on, this is an equation, so it's only true for certain values of x. And there's the value of x we solve. Now if we look at this side here, 3 times x plus 7 is 3x plus 21. So that is true, no matter what x is. If you give this as an equation and have it solved, it'll end up with 0 equals 0, which means x is an element of real numbers. This is an identity, true for all values of x. True for specific values, the equation. True for all values, real values, that is, the identity. So we already have one fundamental identity, and that is the one sine over cos equals tan. We use that a lot in identities. In many of the cases where we see tan, we change to sine over cos. Let's take this as an example. Sine times cos times tan equals sine squared. Now we cannot work with both sides at once. We're supposed to be proving this, so we cannot assume it. So we start with just the left hand side. Sine we leave, cos we leave, but tan we change to sine over cos. Now have a look, this can reduce, the coses can go, and we end up with sine, which gives you sine squared, and that is the right hand side. So identity proven. Let's try a few more. Here we are, tan squared times cos squared. So what do we do? The tan squared goes to sine squared over cos squared. Tan is sine over cos, so therefore tan squared will square the top, square the bottom of the fraction. The coses go, we end up with sine squared. Here's another one, tan over sine x. So we change the numerator to sine over cos. And because we're dividing by sine, that means multiplying by 1 over sine. It just makes it a bit easier than dealing with fractions within fractions. That gives you 1 over cos. Then we have the Pythagorean identity. Very important identity in trigonometric identities. If we take sine squared theta plus cos squared theta, well, if you remember, the definition of sine is y over r. The definition of cos is x over r. So we end up with y over r all squared, x over r all squared. Bit of algebra. Common denominator now. Now, y squared plus x squared is in fact equal to r squared. That's the vertical, that's the horizontal, that's the hypotenuse. So therefore I can write r squared over r squared, which is 1. So there we are, sine squared plus cos squared equals 1. Now that can be adjusted and used as a fundamental identity. We can write sine squared equals 1 minus cos squared, or cos squared equals 1 minus sine squared. Any one of those three can be used without having to give a reason. So let's have a look at this one now. 1 over cos squared minus tan squared. First step, get rid of the tan squared, change to sine and cos. There we are. Now, trigonometric identities, to a big extent, involve algebra. Probably more than 50% of the work is algebra. So here we have two fractions, the one subtracting from the other. So we find a common denominator, which will be cos. That has not changed, that has not changed. So on the top line we'll have 1 minus sine squared. Now we recognize 1 minus sine squared. There we are. 1 minus sine squared is cos squared. So therefore we can take that and write cos squared, and that gives us 1. 1 over cos squared beta minus 1. Algebra first. There we are. Common denominator. 1 minus cos squared beta over cos squared beta. 1 minus cos squared is sine squared. There we are. And sine squared over cos squared we can write in a simpler form. It's not very often we go back the other way, but sine over cos is tan. Therefore that is tan squared. That is simpler than writing the fraction like that. But here we go with the algebra. Sine minus sine theta, cos squared theta. Now, there's nothing you can do with this trigonometrically at the moment. Nothing. But we can go algebraically and we can take out a common factor. There we are. Take out the sine and we're left with 1 minus cos squared. Oh, there we go again. 1 minus cos squared is sine squared. So therefore we end up with sine cubed. Sine minus cos, all squared. Now you got to see this quite often. Remember the pattern to square a binomial? You square the first, multiply the two together and double, square the last, ending up with a plus. So we'll end up with square the first, sine squared, multiply the two together, minus sine cos, and double, minus 2 sine cos. Square the last, plus cos squared theta. Now have a look. Sine squared plus cos squared. Let's put them together. And that, of course, is 1. Now, I say keep this in mind for future reference because you will often in the future see 1 minus 2 sine cos, or in fact 1 minus sine 2 theta, which later you'll find is another form of this, and you need to go back the other way to get to there. Right, so let's have a look with trigonometric identities. First we'll change tan to sine and cos. Secondly, plenty of algebra. There's brackets multiplying out, common denominator, whenever you're adding or subtracting fractions, factorizing, plenty of factorizing. Be observant. We have our fundamental identities, so we must remember them. 1 minus sine squared, 1 minus cos squared, sine squared plus cos squared, sine over cos. And we need to recognize these to be able to substitute. Let's do some simplifications. What I'll do is I'll give you some hints along the way, and you can pause and try them, and then check up. There's the first hint. Change to sine and or cos. Yes, there we are. And that's just algebraic. The coses cancel, so we end up with sine squared. Straight off we say, well, observe. Cos squared. Number 3. Algebra. You'll notice you can do some algebra there. Yes, take out a common factor. And then we observe the 1 minus cos squared is sine squared, and giving you sine cubed. Number 4. Change to sine and cos. Now remember, when you're dividing by a fraction, you multiply by the inverse. So we're going to divide by sine over cos. We're now going to do algebra. So instead of dividing by sine over cos, we're going to multiply by cos over sine. That gives us cos. Number 5. Observe. Sine squared over cos squared. Observe. Where have we seen sine over cos? Tan squared. Number 6. Observe both sine squared over cos squared, and we observe again, same as number 5, tan squared. Number 7. Have a look at it first. 2 terms. What do you notice? you have some algebra to do there. Those two terms have a common factor of tan squared, leaving you with sine squared plus cos squared inside. I've written it the other way around, just by matter of habit, but whether you write cos squared plus sine squared or sine squared plus cos squared does not matter. Observe sine squared plus cos squared. Yes, that's 1. A few more without the hints. Number 9. 2 ways to do, no, just 1, sorry. Notice sine squared plus cos squared is 1, minus 1. Change to sine and cos. That there is cos squared. We have algebra, give you sine squared. This is the one where there are 2 ways you could do this. We recognize sine squared, cos squared. So I'm going to bracket them off. Notice the sign change now. If you take away these brackets, you'd be back to minus cos squared. And that gives you 1 for that, which means 1 minus 1 is 0. Instead, of course, you could notice just the very first 2 terms and observe and say, well, 1 minus sine squared is cos squared. Minus cos squared gives you 0. Number 12. There are 2 steps you can do there. They're both observation steps. Yes, sine squared over cos squared, and 1 minus sine squared is cos squared. Now all I've done is I've multiplied cos squared times 1, cos squared times sine squared over cos squared. And that gives you 1. There's that same thing we had before, except it now has a plus instead of a minus. Square out. Be observant. You'll notice there at the beginning and end is sine squared plus cos squared, which becomes the 1. Number 14. Yes, change to sine and cos first. Now we can do our algebra. I found a common denominator, which gives me sine squared plus cos squared plus sine squared over cos squared, which is 1 over cos squared. Multiply, you get 1 over cos. Here, of course, we could have gone the other way and said cos times sine over cos, sine squared over cos, but you'd have still needed to find a common denominator. Now we're into the proving of trigonometric identities. Now remember what I said, you have to start with one side only and try to get it to the other. Now there are a couple of guidelines with trig identities. You need to decide whether to start with the left or right. First of all, it is easier to simplify than to complicate. So it's essential to start with what appears to be the more complex side. What tells you more complex? Well, addition and subtraction as opposed to multiplication. Having tans on the one side and non-tans on the other, but this doesn't matter. So this case, this one we're going to take the left-hand side because we have a tan squared, which then gives us a fraction leading to common denominator. So left-hand side. Tan squared has become sine squared over cos squared. Now we have to do the algebra. Common denominator of cos squared. Cos squared has gained nothing, so sine squared gains nothing. 1 has gone to cos squared, so sine squared must go to sine squared cos squared. If you picture that over that again on its own, the cos squareds would cancel and we'd end up with the sine squared. Now, on the top line, we have some algebra to do. We take out a common factor of sine squared, and we have 1 minus cos squared, which gives us sine squared. Now, there are a couple of options here. I could now say, well, I've gone the full pack, so I'm going to go to the right-hand side and say, well, right-hand side is sine squared over cos squared times sine squared, which is now equal to the left-hand side. Or instead, I could have gone to sine squared over cos squared, taken those two together and left that separate. Now there's my sine squared over cos squared, which gives me tan squared sine squared, which is the right-hand side. It's very clear which is the more complex here. We have tans on the left and no tans on the right. So I'm going to start with left-hand side. Notice what I've done first. I've been observant and I've seen, hang on, 1 minus tan squared. Now instead of wildly going into change it to sine and cos, I've said, well, let me factorize that as a difference of squares, because now I can cancel there. So there we are. Now I can go by change. Change to sine and cos. Now here's a couple of options. I could go straight there, which is finding a common denominator on the bottom. And when you divide by a fraction, you multiply by the inverse. So there's the answer, which is the left-hand side, right-hand side. Or instead, I could use this technique. You're used to cancelling down in fractions. It's dividing top and bottom by the same thing. Now, there's nothing to stop me multiplying the top and bottom by the same thing. If you find this confusing, go that way. But I'm really multiplying by 1. But how have I chosen it? Because it'll cancel out that cos below there. So there we are. It's sort of like cancelling up. So if you have a look, 1 times cos on the top line, and on the bottom line I'll have that times cos. Top line gives me cos. The bottom line, cos times 1 is cos. Cos times this one, the coses cancel. So we'll end up with that. And there's my right-hand side. Here's some identities to prove. Try them yourself. What follows hereafter is the solutions to them. Okay, let's look at the first one. Left-hand side, more complex because it has tan. I'm going to have to do algebra. So I've multiplied out the left-hand side. Squared the first, multiplied the two together and doubled, squared the last. Now I'm going to change to sine and cos. There we are. Multiplying out, we get that there, cos squared, sine squared over cos squareds cancel. Cos squared times 2 sine over cos, well, that cos goes into there, giving us a cos times the sine on the top, and then cos squared times 1. Now if you look at this and look at that, they are the same thing. I just need to factorize that one. And it's equal to the right-hand side. Number 2. Now here's a case where both sides are going to have to be simplified, so it doesn't really matter which you start with. So I'm going to start with the left-hand side. I'm going to multiply out. Oh, you don't even have to actually go that way. Yes, I've gone the other way. I've done it just on one side. No, sorry, I'm getting confused. I've actually done the left-hand side, and then the right-hand side I've written as sine over cos, which with a common denominator gives me that, and now we have the left-hand side and right-hand side the same thing. Instead, you could have put sine squared over cos squared, that over that over that, which will actually give you that as well. That's the way I thought I was going. This one involves algebra. Yes, plain factorizing. There you are. Top line, difference of squares. Leave the bottom for now, because if you have the foresight, you'll see that in fact this is going to give you that as one of the brackets. Cancelling, we end up with sine squared plus cos squared. Well, that's 1, which is the right hand side. Next one. Now, while that looks more complicated, we have tan on the left. So I'm going to simplify on the left hand side first. So, common denominator. Sine squared minus cos squared, sine squared plus cos squared. And of course, there is our Pythagorean identity, and therefore we have the same as the right hand side. Number 5. Any prizes for guessing which is more complex side? Yes, we're going to take the left hand side and we're going to change to sine and cos. Now here's the option. Alright. Sine squared, so I found a common denominator there, cos squared plus sine squared over cos squared, and left the bottom as it is. That becomes the top line, which is 1 over cos squared, there it is, multiplied by the inverse, which gives us what sine squared times, that cancels, 1 over sine squared, 1. But notice I can use that technique I spoke about a little while back. That is, I can multiply top and bottom by cos squared, because it'll cancel out these cos squareds. I'm really multiplying by 1. Which means we're going to end up with sine squared. Cos squared times the top gives you cos squareds cancelling, and that's 1. Cos squared times the bottom gives you sine squared with the cos squareds cancelling, and that gives me the right hand side as well. But if you prefer, do this way. Many people find this a bit confusing. Right. Left hand side. Change to sine and cos. Now we have to go the algebra way. We're going to find a common denominator. Notice once again, good old Pythagorean identity. There we are, right hand side. The left hand side once again has tans in it, so I'm going to go that way. I'm going to say 1 minus sine squared over cos squared, and below sine over cos. Top line, find a common denominator of cos squared. Bottom line, leave. Which means now I'll, dividing by that means I'll multiply by the inverse. Cos cancels into cos squared, give you just cos times the sine. That's as far as we can go on that one. But now we're going to go to the right hand side and we can factorize that. There it is there. And have a look. There's our Pythagorean identity, which means that we have down to what the right hand side ended up as. The left hand side ended up as. Sine squared plus cos squared is 1. Obviously left hand side, change to sine and cos, common denominator on the top line, now we're going to multiply by 1 over 1 plus cos. Notice that I've now factorized the top line as well, and cos plus 1, 1 plus cos, same thing, so I end up with just the sine left and the cos left, and sine over cos is tan.